And welcome back to the Turdferg Network. All right, in today's video, we are completing the lab about reactivity of metals in a single replacement reaction. So in this lab, we did tests to try and see, for example, will copper and HCl react? So you were supposed to mix those together, and somewhere you should have for me you should have some form of description, or you may have just wrote nothing because nothing happened when you reacted those two. This one you're supposed to react copper, you're supposed to mix that with cupric chloride. But anyway, so that was the whole purpose of this lab. You trying to determine out of all these elements, which one of these actually had a reaction. And I believe the grand total, I think there should have been 8 reactions in this. Well, let's go ahead and do something. Let's look at some requirements I want you to have in this lab. I want you to give me basically an equation list. In other words, I want you to go ahead and tell me what should happen. Because you see, here's the thing. This is not something we guess at. This is something we know. So I'm going to go up here and do A first. I'm going to start there. So our first reaction, you took copper and you tried to react that with hydrochloric acid. Will that react? Well, I've given you what's known as an activity series over here. And the general idea, this is very easy. For something to react, the free element, the single element has to be more active. So, in other words, what I am referring to here in this is that the free element has got to be higher on this list than what it's trying to bond with. So, for example, Cu plus HCl. Cu, and there's Cu, copper has to be higher up on this list than H. So, in other words, copper can only react with the things that are below it. Well, that's really narrowing this down. That means that copper cannot, in other words, copper cannot react with hydrogen. It's not going to happen. So that means you should have had no reaction for this first one. Let's kind of go down through this list a little bit. So for the second one, you should have had copper. I'm going to go and do some copper plus, 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 plus. See, we tried to react copper with copper. Well, this sort of make common sense. If you try and replace copper with copper, nothing's going to happen. The next one, we had copper plus MgCl2. So how about this one? Well, let's take a look at the table over here off to the side. Let's take a look. Will copper react with magnesium? No. Why not? Well, magnesium is up here. Copper is down here. Copper can only react with things that are less active than it is. So we can go ahead and call this one a big old no reaction. How about copper plus next? FeCl3. How about this guy? Let's see. Is copper higher than, and what I'm doing, is copper higher on this list than what it's trying to replace? Copper is not. So this one's also a no. Now, let's get to the next one. Is copper, we're trying to react with silver nitrate, is copper higher on this list than silver nitrate? And believe it or not, finally, copper is more active than silver, which means this one will react. So what's going to happen, it's kind of like stealing somebody's girlfriend here. Copper's going to slide in, and it's going to knock that silver out of this place. In other words, they swap places. So on the other side, silver's going to be all by itself. Aw, the silver ends up all by itself. And the copper takes this NO3. It trades places. Now we need to do something. Copper is a +1, NO3 is copper is a +2, CO3 a -1, which means we need a parenthesis 2 on this to complete that reaction. Anyway, so what I want you to do is go through this list. Go through this list Each one, I've already done copper, so next you'd move on to Mg, Mg plus HCl, and go ahead and try and tell me, each one of these, will they react? Well, let's see, Mg plus HCl. Let's clear all this stuff out of my way over here. So for Mg to react with H, there's Mg. Mg has to be higher on this list than H. Let's see. Well, there's H way down here. So yes, this is a reaction. So the H is going to end up all by itself on the other side. And the Mg is going to pick up the Cl. But please take note of something. Plus 2 minus 1, which means that's going to need a 2. And then this is almost a little hint for you right now. See how that's got H2 in here? Hydrogen hates to be by itself, so it forms what's known as a diatomic molecule. But just continue through this list. And here you go. Here's the big one, 8. 8 of these ought to actually have a reaction. So you ought to have, when this is done, there's 1, 2, you ought to have a total of 8 balanced equations up by the time you finish this one. So that's what you want to do. So what about conclusions for this lab? Let's insert a blank page. What about conclusions? Conclusions. All right. After you've done this lab, A, B, C, D, E, F, so forth, you're to have, and probably a bunch of them say no, but you're to have a bunch of observations you wrote, and now you've got this huge equation list. What I want you to do is this. Check yourself. See if you were right. For A, we had, on that page a second ago, we had Cu plus HCl, and we said there would be no reaction. How about this? Now compare that to what you did in the lab. Did you say that there was no reaction to that one in the lab? A lot of people mess that one up because the copper gets, when you put that piece of copper in that acid, you'll notice something. It gets very, 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 very shiny, and everybody thinks it's reacting sometimes. Hydrochloric acid is not reacting with the copper. It's simply cleaning it, and that's the reason for the shininess. But go down through your list, A, B, C, D. I think E ought to be the first one. I bet you said something like silver caterpillar here, or caterpillar. I can't spell caterpillar. But anyway, you probably said something about that piece of copper looking fuzzy. When you did copper and silver nitrate, what you probably noticed when you did it, you probably noticed this. It started doing this as the lab went on. What in the world is happening to that one? A, B, C, D, E. Well, go back. We did this one a second ago. We took copper plus AgNO3, and when we completed the reaction, we had Ag plus CuNO3 2. Wait a second. Give you a hint. What's that silver looking stuff? Well, it's the silver. One of the things we produced in that one was silver. So this explains it. Probably, I'm going to be willing to wager on F. On F, I bet you saw bubbles. Bubbles! And when you saw those bubbles, here's the thing. Mg plus HCl, one of the byproducts you made was hydrogen gas. That's what those bubbles were. Those bubbles you saw. Bubbles! That was that hydrogen being made. So what I want you to do is in your conclusion, that's not what I want. In your conclusion to this lab, in your conclusion, all I want you to do is to compare these two lists. Do all of your lab, do all the observations you made in the lab, observations, do all these match? In other words, every one of these over here in this equation list, does what you have here compare to what you saw in lab? So I want you to go back in that conclusion and just tell me, did everything react that was supposed to? Did everything react that should? And for that matter, did you see any react? Did you see any? You see any react that shouldn't? And that's an easy explanation. If you saw a reaction, and according to what we've just done here, according to this, they weren't supposed to react, it means you probably got some cross-contamination in there. But anyway, that's all I want for a conclusion. So I want to thank you for watching this video today. I know it's so exciting. So I tell you what, adios, goodbye. Oops, misspelled it. All right. And if you are still watching, here you go. I'm going to help you out. If you can give me a balanced equation for each of those equations, let's go back. By the way, here is the answer. So if you've watched this far, here is all the ones that should have reacted. If you want to double check your answers, I went through and made this little chart out. But all the ones that were supposed to react, if you can take it one step further, Cu plus AgNO3, and that makes Ag plus CuNO3 2. And again, I did that because I'm a plus and minus kind of guy. Plus 2 minus 1. If you can take it one step further, I think the next one, Mg plus HCl, yields H2 plus MgCl2. Again, that's plus 2 minus 1. So explaining why I'm writing while I'm writing. Let's see. Next one is Mg plus, what is this? Mg plus Cu. Then Mg plus FeCl3. Mg plus Ag. So here's everything that should have reacted. And I'm talking real secret so nobody knows I'm doing this. Fe plus HCl. Fe plus CuCl2. And then the last one, Fe plus AgNO3. So that means, let's see if we can finish every one of these. See, this one would have been Cu plus MgCl2 again. The next one, now this one's going to be a little more neat. Fe plus Mg, and this is where people mess up. Mg is a plus 2. Cl is a minus 1. So this is still MgCl2. Just because you saw a 2 on that, or 3 on that side, doesn't mean it goes to the other side. The reason I put a 3 there is because that's a plus 3. So let's keep going. This one would be Ag plus MgNO3 2. Again, that's because that's a plus 2 minus 1. Fe would be, let's see, H would be all by itself, so it becomes H2, so you should have saw bubbles on that one. And then we've got Fe plus 3, Cl minus 1. And then on the next one, we've got Cu by itself. So that one should turn red, and that's the copper. So that one's kind of neat. You should have a bunch of black iron in there. And what's neat is when you put in the copper chloride, it should have started turning red inside there. And that was that copper that you were seeing get made. Plus, one more time, this would be FeCl3, because that's plus 3 minus 1. And then the last one would be Ag. You should have saw silver in it. Plus FeNO3 3. Yep, that's right, because that's plus 3 minus 1. And now, these are the equations you should have listed. But now I'm going to go ahead and do something. If you can remember how to balance these equations, I'll let you have a little bonus points. If you balance these equations, in other words, if you've forgotten, go back and watch a video on balancing. But I need here, I've got two ends on the right side, but only one end on the left side. So that means if I put a 2 here, that gives me 2 silvers. So I need a 2 right here to balance out the silver. Now I have two ends, 6 O's and 6 O's. This was a balanced equation. The next one, we got 2 H's on this side, so I put a 2 right here. And that gives me 2 H's and 2 Cl's, which is fine because I also needed 2 Cl's over here. Let's see, the next one is actually, this equation's already balanced, so it's good. Ooh, check the next one out. 3, and what do you do when it's 2 and 3, or 3 and 2? What do you do? See how this one you got 2 and a 3? No problem. All I got to do is put a 3 here, and that'll get me 6 Cl's, and put a 2 here, and that gets me 6 Cl's. Now you should be looking at this going, hey, but you jacked up the mg and the fe. Hey, no problem. I'll put a 3 in front of the mg, and that gives me 3 mg's on both sides. And then I'll put a 2 right here in front of this fe, and I'll balance it. So if you go through, and I've just balanced half of them, if you go through and finish balancing the rest, I'll make sure and hook you up a little bit in terms of the lab book. A couple of bonus points if all these are balanced out right, which it's the next thing we do in class. That should help. But anyway, now this video I can say is officially over. Officially over. Officially.